Space does not behave the way we expect it to. Not when we look closely enough, and not when we listen long enough. From Earth, the universe appears calm and distant, a silent backdrop of stars and galaxies frozen in time. But beyond what our eyes can see, space is in constant motion. Fields shift, particles collide, radiation flows, and invisible forces pull and stretch reality itself. Most of this activity fades into background noise, an endless cosmic hum that scientists have learned to ignore. But sometimes, something cuts through that noise, something precise, something deliberate. For decades, NASA has relied on instruments designed to observe patterns, not just images, but behaviors, repetition, timing, direction. When something in the universe repeats itself with accuracy, it demands attention. Planets orbit, pulsars spin, stars pulse, but these natural processes follow rules we understand, or at least rules we can model. What unsettles scientists most is not chaos, but order where none should exist. Several years ago, a set of deep space monitoring arrays began detecting an anomaly. At first, it was dismissed as interference, a slight irregularity in a narrow frequency band, barely distinguishable from the cosmic background. Engineers logged it, adjusted filters, and moved on. But the signal returned, again and again, always at the same frequency, always from the same region of space. A region that, according to every existing map, contained nothing of interest at all. That region was cold, empty. No stars, no gas clouds, no known objects capable of emitting energy at the detected levels. And yet, the signal persisted. It did not drift, it did not weaken, it did not behave like noise. It behaved like a transmission. NASA analysts began comparing the data against known astrophysical sources. Pulsars were ruled out almost immediately. Their emissions are regular but imperfect. They wobble, they decay. This signal did neither. Quasars were considered, then dismissed. Too powerful, too chaotic. Black holes were a possibility, but black holes do not emit structured signals on their own. They consume, they distort, they do not announce themselves with precision. As the weeks passed, the anomaly became impossible to ignore. Multiple independent instruments confirmed the same readings. Satellites separated by thousands of kilometers were detecting identical patterns, eliminating the possibility of localized interference. Whatever the source was, it was real, distant, and consistent. The most unsettling feature of the signal was not its strength, but its timing. The intervals between pulses were exact, not approximately regular, exact, down to fractions of a second that natural systems rarely maintain for long. Even atomic scale phenomena tend to drift over time. This did not. It was as if the signal was being governed by a clock. Inside NASA, discussions grew tense, not dramatic, not panicked, just quiet and serious. When scientists encounter something truly unknown, the mood changes, the language becomes careful, hypotheses are phrased conservatively, and information stops traveling freely. Some researchers proposed an explanation rooted in physics not yet fully understood, perhaps a new form of matter interacting with space-time in an unexpected way, perhaps a quantum resonance amplified across cosmic distances. These ideas were explored, simulated, and ultimately failed to account for the signal's stability. Nature is efficient, but it is rarely so precise without variation. Then, the signal changed. Without warning, the pattern shifted, not in frequency, but in structure. The pulses began grouping together, separated by longer periods of silence. It was subtle but measurable. The signal was no longer a simple repetition. It now carried hierarchy, clusters, pauses that felt intentional, like punctuation. At this point, comparisons to past anomalies became unavoidable. The WOW signal, detected in 1977, had shown similar qualities of strength and narrowband precision, but it lasted only a brief moment. This was different. This signal endured. It evolved. NASA did not announce the discovery publicly. No press conference, no statement. Officially, there was nothing to report. Unofficially, the data circulated among a small group of researchers tasked with one goal: determine whether the signal could be artificial without assuming that it was. This distinction mattered. Science does not ask, "Is this aliens?" It asks, "Is there any known natural process that can explain this?" Only when the answer is no does the question become uncomfortable. Months passed. The signal continued to arrive. Then, during a routine recalibration of tracking arrays, something unexpected was noticed. The apparent origin of the signal had shifted, not randomly and not due to Earth's motion. The source itself appeared to be moving, slowly, deliberately, as if it were adjusting its position relative to us. Space is vast beyond comprehension. Distances are so extreme that movement on a cosmic scale usually unfolds over millions of years. Yet here was a source changing orientation within human timescales. Not fast, but perceptibly, enough to suggest agency. The idea was not spoken aloud in official meetings. It did not need to be. Everyone in the room understood the implication, and everyone understood the risk of stating it prematurely. Science has been wrong before, catastrophically wrong, and nothing damages credibility faster than speculation without proof. Still, the data remained. Then came the silence. One day, without warning or transition, the signal stopped. No fading, no distortion, no residual noise. One moment it was there, following its established pattern. The next, the frequency band was empty. Instruments continued recording, expecting a return. None came. Follow-up observations intensified. NASA redirected resources. Other space agencies quietly joined the search. The region of space was scanned across multiple wavelengths: radio, infrared, X-ray, gamma. Nothing. No object, no energy source, no trace that anything unusual had ever existed there at all. Natural phenomena leave fingerprints. Supernovae leave expanding shells. Pulsars leave radiation trails. Even transient events echo in surrounding space. This left nothing. It was as if the universe itself had erased the evidence. Official explanations were conservative: an unknown astrophysical process, a statistical anomaly, instrument misinterpretation. Yet none of these explanations satisfied those who had studied the raw data. Too many independent confirmations, too much internal consistency. There is a concept in astronomy known as the cosmic dark forest. The idea that advanced civilizations, if they exist, might choose not to broadcast their presence, not out of fear, but out of strategy. Silence in a hostile universe is survival. If such civilizations exist, then the universe would appear quiet not because it is empty, but because everyone is listening and no one wants to be heard. If that idea is correct, then a structured signal that appears, changes, and then vanishes could represent something else entirely. Not a greeting, not an invitation, but a test, a probe, a brief transmission designed to observe who is listening. This is where speculation becomes dangerous and yet impossible to avoid. Humanity has been emitting radio signals into space for just over a century, a tiny bubble of noise expanding outward at the speed of light. Barely noticeable against the cosmic background, but detectable to any sufficiently advanced observer within range. We often imagine that contact, if it happens, will be obvious, a message, a signal we can decode, something unmistakable. But intelligence does not need to announce itself loudly. It only needs to observe patterns, to notice that a species is listening, recording, analyzing, to notice that we react. There is one final detail that remains buried in technical documentation. During the last confirmed detection of the signal, a secondary fluctuation was recorded, extremely weak, almost discarded as noise, but it occurred immediately after the main signal ceased, a brief, complex variation that did not repeat. It lasted less than a second, too short to analyze meaningfully, too structured to dismiss entirely. NASA has never addressed this detail publicly. Perhaps it was nothing, a coincidence, a glitch at the worst possible moment. Or perhaps it was the final act of a process we do not understand, a closing signature, a response to being observed. The universe does not owe us explanations. It existed long before us and will continue long after we are gone. Our instruments are crude compared to the scale of reality they attempt to measure. And yet, every so often, something happens that feels uncomfortably close to intention. If the signal was natural, then it represents a gap in our understanding of physics, a reminder that the universe still holds secrets beyond our models. If it was artificial, then it represents something far more profound, evidence that we are not alone and that we may have already been noticed. Either possibility changes how we see the cosmos. For now, the region remains quiet, dark, empty. Telescopes continue to listen, recording vast amounts of silence in the hope that something, anything, will break it again. Because once you have heard the universe behave in an unexpected way, silence is no longer comforting. It becomes a question. And the universe, as always, refuses to answer.